Alright, so in this lesson, we're going to go over how to find central angles and their intersect and what's the measure of their intersected arcs, and how to find inscribed angles and what's the relationship with them and their intersected arcs. So here, what you're going to learn, So I'm going to go ahead and run through vocabulary words with you. A central angle is an angle in the middle of the circle. And here's an example. That's why they call it central angle. So if I have angle circle P, and I call this D and F, angle right here is called a central angle. And this arc out here is called the intersecting arc. So what I mean by that, angle P, wait, it should be in the middle. Remember, the vertex is always in the middle. So angle DPF, or you can just say angle P, is a central angle. All right, an inscribed angle is an angle formed on the circumference of the circle. And here is what we mean by that. Here we go. So if I call this angle ABC, this angle right here is called an inscribed angle because the vertex of the angle is on the circumference of the circle. And that yellow part is an intersecting arc. And there's a relationship between those two. I'll get to it in a minute. So I would say angle B or angle ABC, where the vertex of the angle is in the middle, is an inscribed angle. Make sure you put these words in your key vocab or copy them down and then post it in there. All right, if you need to, go back and pause and write this down and make sure it's in your book creator. If you write it on paper, just take a picture and stick it in your book creator. Okay, an arc is a piece of the circumference. And here's what I mean by that. So if I have a central angle and I call it ABC, then that's the angle, and where the angle where the segments intersect the arc is called the intersecting arc, and this is called an arc right here. Okay, a semicircle is 1/2 of the circumference, and a semicircle, it equals 180 degrees. And here's an example of that. So if I have a diameter, and a diameter passes through the center of the circle, right here, this is called a semicircle, and the red arc is called a semicircle. And a degree there is 180 degrees. So if the central angle is 180 degrees, the measure of the arc is also 180 degrees. And right here, if this is 180, then this arc is also 180. A semicircle equals 180 degrees. A minor arc is an arc less than 180 degrees. Now I'm going to show you that. So let's say I have a central angle and I say this is 30. And out here is the intersecting arc. And if this is 30 for the central, so is the intersecting arc. Let me change that color. The intersecting arc is also going to be 30. And this is an example of a minor, That's the minor arc. I'm sorry, guys. Oops, let me draw the arrow to minor. That's a minor arc. So this is a minor arc, okay? Any arc that is less than 180 degrees. Okay, this major arc is an arc that is more than 180 degrees. And here's an example. Let's say I have an angle. Let's say that's my central angle, and let's say it's 190. Then this arc out here is also 190. So this arc, since it's greater than 180 degrees, greater than 180 degrees, is called a major arc. Okay, and now an intersecting arc is the arc in between the ends and points of a segment. So here's what I mean by that. If I have a central angle, and I'm going to call this central angle A, B, C, then the intersected arc is the arcs that's in between these two endpoints, that piece right there. So I would say arc AC is, and that's the symbol for arc, is the intersected arc of angle ABC. And you can use a symbol for angle if you would like. And there you go. All right, so let's get some quick things done. So I already just showed you a central angle. If this is a central angle here, which is an angle that comes from the middle of the circle to the circumference. So the intersecting arc here is AB, and if the central angle is 60, then that means this intersecting arc here is also 60. So with a central angle, so we're going to say angle ACB is going to be equal to arc AB. So it's always going to be equal to central angle, and the central angle and the arc are always going to be equal to each other when you have a central angle. An inscribed angle looks like this. I'm going to call it ABC, where the vertex is on the circumference of the circle. I'm going to call this 30, and the intersecting arc is right here. And the rule with this, if this is 30, then you double it to get what the intersecting arc is. And the way you can remember this is is small and this one's big. So you have to have a number that's bigger. So you just double this to get the intersecting arc. So we would say the measure, well, angle ABC equals 1/2 of arc AC, or you can say in another way, arc AC is equal to 2 times the measure of angle ABC. So either one of those work. If you're given this, take half of it to get this, and if you're given this, double it to get that angle. All right? So now we just did these. I'm not going to go over those again. So here, this is telling me number one is asking me to find the measure of arc ST. So I'm going to go and highlight arc ST, and you notice that's the intersecting arc of a central angle. So this is the central angle that matches that arc. So we know that central angles mean that you take the angle and set it equal to the arc, because they should equal, and then you use your math to help you find the measure of the angle. So we'll use your math to help you find x, and once you find x, you substitute it in to find the arc. So I'm going to plus 5 to both sides. 17x equals 16x plus 7, and then this variables on the wrong side, so I'm going to minus 16x from both sides. and I get 1x equals 7, and then we divide by 1, and x equals 7, so that means arc ST would be equal to 16 times 7 plus 2, that's going to be 70 plus 42, that's going to be 789, so that's 112 plus 2, so arc ST is equal to 114. So this arc is 114 degrees. Okay, and then the next question said, is ST a major arc or a minor arc? So for part 2, ST, it's less than 180. So ST is a minor arc because it's less than 180 degrees. All right, so you can pause this to write this down, or you can yeah, you're gonna have to pause. So I'm gonna go ahead and clear the page. All right, so the second one, it says use the figure to find the measures of x, y, and z. Okay, so it wants me to find this intersecting arc, and these are inscribed angles. So this is the angle right here, and the rule is if this is the inscribed angle, then to find the intersecting arc, then you're going to double this. So x is equal to 120. On the next one, this is the intersecting arc for this angle. That's an inscribed angle. I know this is 140, so to get y, I'm going to take half of it, and it's going to be 70. All right, and the last intersecting arc is right here, and the angle is this here, and I need to figure out what is z so I can find, well, I don't need to find this angle, but I do need to figure out what z is. There's a couple of ways you can approach this. This is a triangle. So if this is a triangle, I need to find the third degree, and I know if I add all three of these together, then it should, this plus this should give me 180. So I do 60 plus 70 is going to be 130. So if I do 180 minus 130, that would give me 50. So that means this right here is 50. And since this is an inscribed angle, I just double it to get z, which is going to be 100. So z equals 50 times 2, which is 100. Okay, so you go ahead and try out this one, and then I'll see you guys in class. Try this one out. It's in your book, and I'll see you in class. Bye.